We will now evaluate the model, predicting the test set results. We make the confusion matrix, calculate the accuracy and the points in the ROC curve. ROC basically stands for Receiver Operating Characteristic Curve. We find that the accuracy of the model is 0.76, which basically stands for 76% accuracy. We import CBOT. We need to understand that the accuracy, a 76% accuracy, is not bad since the machine is predicting the results on the test set on and not on the model on which it is trained. Hence, it may encounter unseen or situations where the model has not been tried out before. We then import a CBOT library to create the data frame with the confusion matrix values and plot the confusion matrix. This is We then plot a heat map for the confusion matrix, and this is the depiction of the heat map. Plot the receiver operating characteristic curve, and we see that the area under the curve is 0.77, with the y-axis representing the true positive rates and the x-axis representing the false positive rates. Being curious about the times when we give a word appears in negative reviews, times it occurs in positive reviews. Bigger the ratio that is greater than 1 means that the word is indicative of a negative review, and smaller ratios means that the indicative word is a positive review. We then have the binarized naive Bayes. Maybe it is only a matter whether a word is in the review or not the frequency of the word. So instead of frequency of a token, our term document matrix will only contain 1 or 0 as the values. This step simplifies the model and sometimes it can produce better results. We create the term document matrix binarized containing only ones and zeros if the words is in the text or not. The same step is repeated several times but using binarized term document matrix. Find that the accuracy is 77.6% now, or 0.776 compared to the previous value of 76.36%. Hence there's a marginal increase. It helps us to improve our model. Now fit the logistic regression where the features are the unigrams. We get an accuracy of 80.76% on the unigrams of our naive Bayes approach. Trigrams with naive Bayes feature. Our next model is a version of logistic regression with naive Bayes feature described here. For every document, we compute binarized features as described above, but this time we use bigrams and trigrams as well. Each feature is a log count ratio. Logistic regression model is then trained to predict if it is real or fake. N-grams. An n-gram is a continuous sequence of items where the items can be characterized as syllables or words. A 1 gram is a unigram, a 2 gram is a bigram, and a 3 gram is a trigram. Here we refer to the sequences of words. So examples of bigrams include the dog said that, and can't you. Notice how each of these have two syllables. There are, these are short words. We then set the minimum value as 1, indicating it's a unigram, and the maximum value of n max n being 3, indicating it's a trigram. We tokenize the documents and select the feature counter to count the tokens and list them. Then append these tokens. We create a diagram document matrix, and train the ngram document matrix. And then we create the validation matrix. And these steps are similar to the ones performed before. Results are similar to the logistic regression, but better than the previous naive-Bayes model. That is, performs with an accuracy of around 80%. The binarized naive-Bayes performs with an accuracy of 77%, which is lesser than the accuracy mentioned above. That is 80% above, but right now it's 77%. We fit logistic regression with the diagrams, and we use count vectorizer to compare the results. We have a list of words. Or using count vectorizer, we count the number of times these words occur. We have a long list of words here, along with the count vectorized values of each of them. It's a long list, as you can see. It's a very long list indeed. Then we form the value of ngram document, where we vectorize and transform the test data, and use logistic regression using ngrams from count vectorizer for binarized naive Bayes. Logistic regression using ngrams, and we find that the prediction accuracy of for the binarized values is 79.7%, which is lower than that of the naive Bayes we tested for the training data. Hence, you can account those to the unknown or unseen values present in the test data.